Hello everyone, I'm Dr. Manju Gupta, Department of Chemistry, St. Aloysius College, Jabalpur. Today I'm going to discuss or explain about another class of compounds containing hydroxyl group or OH groups, that is phenols. History of phenols. Phenols was discovered in 1834 by Frederick Runge, who extracted it from coal tar as in impure form. Runge called phenols as coal oil acid or carbolic acid. Coal tar remained the primary source until the development of the petrochemical industries. From the middle fraction of coal tar, the phenol can be extracted. In 1841, the French chemist Auguste Laurent obtained phenol in pure state as a pinkish crystalline solid. In 1836, Auguste Laurent coined the name phen for benzene. This is the root of the word phenol and phenyl. In 1843, French chemist Charles Gerhardt coined the name phenol. Phenols, sometimes called phenolics or sometimes called carbolic acids, are a classes of compounds consisting of a hydroxyl group bonded or connected directly to an aromatic hydrocarbon group. This aromatic hydrocarbon can be in the form of benzene, or sometimes it may be in the form of naphthalene and some more condensed aromatic rings. Phenols are hydroxyl derivatives of hydrocarbons formed by replacing a hydrogen on the benzene ring of an aromatic hydrocarbon with the hydroxyl group. If we replace one of the hydrogen of benzene by OH, then we get phenols. Structure of phenol. The alcohol functional group consists of, the phenolic functional group consists of, not alcoholic, there is a mistake. The phenolic functional group consists of oxygen atom bonded to sp2 hybridized aromatic carbon atom and hydrogen atom via a sigma bond. This is the oxygen which is bonded with the oxygen sp2 hybridized carbon of the benzene ring, and by the sigma bond it form a bond with hydrogen. Both carbon oxygen and oxygen hydrogen, both bonds are polar, and conjugation exists between an unshared pair of electron of the oxygen and the benzene ring. That means the lone pair of electrons present on the oxygen atom extends the conjugation of the benzene ring. Because of this extension of conjugation, this results in a shorter carbon-oxygen bond length, more basic OH group in which phenolic molecule can easily donate OH group, and a more acidic OH proton, and in some of the reaction it can easily release OH proton from OH group. Nomenclature of the phenol. Functional group suffix commonly used as phenols, but when we have to use as a prefix, hydroxy is used. First rule of nomenclature: locate the position of hydroxyl group attached to the benzene ring. Benzene rings attached to more than one hydroxyl group are labeled with the Greek numeric prefixes such as di, tri or tetra to denote the number of similar hydroxyl group attached to the benzene ring. For example, if to the benzene ring 2 hydroxyl groups are attached, so it is called benzene 1, 2 or 1,3 diol. In the case of substituted phenols, that means any other group is present other than OH group. Locate the position of the other functional group with respect to the position where the hydroxyl group is attached. That means hydroxyl group is considered always as the priority. It will give the number 1. Depending on the position of the substituted functional group, with respect to hydroxyl group. Words like ortho, when the functional group is attached to the adjacent carbon atom, or it is known as 1,2 substitution. Para, when the functional group is attached to the third carbon atom of the hydroxyl group, that is para or 1,4. When the functional group is attached to the second carbon atom from the hydroxyl group, that is 1,3, or meta. These terms are also used for the nomenclature of phenol. In common terms, ortho, meta, para terms are used in common language, or if we discuss the IUPAC nomenclature in the literature, 1,2, 1,3 or 1,4 substitutions are used. For example, OH phenol with on the para position CH3. The common name of compound phenol with CH3 group is the cresol. When CH3 group is present on the meta position, then it is known as metacresol, or in the IUPAC nomenclature, it will known as 3-methyl phenol. Second structure is the, at one position there is OH. Start the numbering from the OH, 1, 2, 3, and at third position there is CH3. At fifth position there is Ca. Two substituents are there other than OH in the phenol group, phenol molecule. According to the alphabetical order, first we write chloro, then methyl. 5-chloro, 3-methyl phenol. As in the case of 2-hydroxyl group attached to the benzene ring, the common name is resorcinol and the IUPAC name is benzene 1,3-diol. Similarly here OH, COOH, we give the priority to the carboxylic acid group. So OH is considered as the prefix. In case of instead of writing phenol, we write OH or the hydroxy. Parent molecule will be benzoic acid, and at the benzoic acid, in the benzoic acid, at fourth position, OH or hydroxyl group is present. So its name will be 4-hydroxybenzoic acid or para-hydroxybenzoic acid. Another compound is again ketone compound. Again, we give the priority to the carbonyl group. Parent molecule is acetophenone. In the acetophenone molecule, at the second position, there is OH. At the fourth position, there is CH3 or methyl. According to the priority order, we write 2-hydroxy, 4-methyl acetophenone. These are few more examples. For example, when CH3 is attached to the adjacent carbon, then it is known as orthocresol or 2-methyl phenol. When it is present on the third position, then it is known as metacresol or 3-methyl phenol. When at one position OH is there, two position NO2, then it is known as orthonitrophenol or 2-nitrophenol. When two OH groups are attached at the adjacent carbon of the benzene ring, then it is known as 1,2-benzene diol or catechol. When they are attached at the 1,3 position, then it is known as 1,3-benzene diol and or resorcinol. Common name is resorcinol. When the two OH groups are present at the para positions to each other or at 1,4 positions, then it is known as 1,4-benzene diol and its common name is hydroquinone. Next compound is 2 bromo atoms are attached with the OH. Its name will be 2,6-dibromophenol. Similarly, since phenols are the compounds in which OH is attached with the aromatic hydrocarbon. Aromatic hydrocarbon can be anything. Here aromatic hydrocarbon is naphthalene. When OH is attached with the naphthalene, then it is known as naphthol. If it is present at the first position, then it is known as 1-naphthol or in common name alpha-naphthol. If it is present on the second position, then it is known as 2-naphthol or common name is beta-naphthol. So this was about the nomenclature of the phenols. Now we come to the preparation methods of the phenols. Phenols are synthetically most important compounds. Phenols can be synthesized by various methods. First method is from diazonium compounds or salts. First, we'll see what do you mean by diazonium compounds and how they can be synthesized. So first step is the formation of diazonium ions from aromatic amines. Diazonium ions are formed by the primary aromatic amines. By the reaction of primary aromatic amines in concentrated acidic medium with dilute sodium nitrite or nitrite solution. In this condition, HCl and nitrite react together and form nitrosonium ion. This is the nitrosonium ion. Nitrosonium ion is positively charged. Positively charged, that means it acts as electrophile and it attack on the lone pair of electrons of NH2. And first step is the addition of nitrosonium ion. Second step is the proton transfer. This is the proton transfer from HCl, and this species is resonance stabilized. Again, there is the proton transfer. After that, it is converted into diazonium salt, C6H5 and 2 plus. Always diazonium salt is positively charged and counter negative ion is present along with it. Diazonium chloride, if we are using HCl, if we use in place of HCl sulfuric acid, then diazonium sulfate will form. So this is the first step for the formation of diazonium salt. How the diazonium salts can form phenol? When an aromatic amine is treated with nitrous acid at 273 to 278 Kelvin, that means at lower degree temperature, diazonium salts are formed. Diazonium salts are very reactive in nature, and upon warming with water, this and two group of nitrogen, diazonium salt can eliminate as nitrogen molecule, nitrogen gas, and it is converted into a positively charged ion. This positively charged ion can easily obtain OH minus ion from the water and converted into the hydrolyzed in the presence of water or dilute acid and converted into OH. So if we want to prepare phenols from diazonium salt, first we have to prepare diazonium salt from aromatic amines. Generally aniline is used for this. When aniline react with nitrite and any concentrated acid, it is converted into diazonium salt. When diazonium salt is boiled with dilute acidic aqueous solution, nitrogen molecule is eliminated and it the formed positively charged ion hydrolyzed into phenol. Second method for the preparation of phenol from the coal tar. Coal tar is the one of the fraction which is obtained from the fractional distillation of crude petroleum. Phenol is prepared from the middle oil fraction of coal tar distillation. This fraction mainly contains acidic phenol and neutral naphthalene. The mixture is dissolved in NaOH, in which phenol is soluble and naphthalene is insoluble. When phenol gets dissolved in the solution, the aqueous solution on acidification gives the crystals of phenol. Third method is from aryl halide. Aryl halide, any halide can be used, chlorobenzene, bromobenzene. Phenol can be synthesized, for instance, chlorobenzene. The first step of the reaction is the addition of chlorobenzene to a solution of sodium hydroxide in water at 370 degrees centigrade. Initially, or in the first step of the mechanism, the sodium hydroxide dissociates and produce hydroxide ion. Hydroxide ions that deprotonate the benzene ring, forming a benzene intermediate. Since chlorine is electronegative, chlorine will withdraw the electron from the adjacent carbon of benzene. So the hydrogen present on the adjacent carbon can be easily removed by the OH minus ions, and when one of the hydrogen is removed and it is converted into benzene intermediate. Benzene based molecules are also called arynes. In the next step, when benzene is formed, a hydroxide ion attacks one of the triple bonded carbon atom of the benzene molecule. Because the benzene molecule is symmetrical, the OH minus ion can attack either triple bonded carbon atom. Two carbons are attached to the triple bond, so any hydroxide ion can attack any of the carbon atom. The reaction yields a roughly equal distribution of the two products, which are in the case of same. That means the lone pair of electron can be present on the two carbons. So the compound will be formed in the 50-50 ratio. The ionic intermediate in this case then react with water and yielding phenol and a hydroxide ion. This lone pair of electron abstract a hydrogen as a proton from the water molecule and converted into neutral molecule phenol, and OH minus regenerated as the catalyst, which is used for the starting of the reaction. So from the aryl halide, first step is the reaction of any halobenzene to the hydroxide group. In the first step, hydroxide will remove proton from the adjacent carbon attached to the chlorine. It is converted into benzene. In the on the benzene, again there is the attack of hydroxide ion, which abstract proton and converted into which add on the carbon atom and converted into carbon ion. After the formation of carbon ion, again it abstract proton from the water molecule and converted into phenol and regenerate the base catalyst OH minus ion. Next method. Fourth method, phenols can be synthesized from aryl sulfonic acids. Benzene sulfonic acid is reacted with aqueous sodium hydroxide. This is benzene sulfonic acid. Benzene sulfonic acid, when react with aqueous sodium hydroxide, the salt is mixed with solid NaOH and fused at high temperature, 573 temperature. The product of this reaction is the sodium phenoxide. In most of the cases, phenols, before the synthesis of phenol, the starting material is converted into the sodium phenoxide, and when we acidify the sodium phenoxide, we get the phenol. So in the same way, in the first step, benzene sulfonic acid react with NaOH, and at high temperature, when they fuse together, they are converted into sodium phenoxide. Sodium phenoxide is a basic compound. When it is treated with dilute acid, it is converted into phenols. Next method. Next method, from Grignard reagent. Grignard reagents are very important synthetic compounds. They are generally used for the synthesis of every class of compounds. For the preparation of phenol, obviously we required a Grignard reagent molecule which is having the phenyl group. Phenyl magnesium bromide, in the presence of excess oxygen and in acidic water, yields phenol. The mechanism of the reaction. First step. In the first step, oxygen adds to the one of the molecule of phenyl magnesium bromide. When it adds to one molecule, the another molecule react together and converted into C6H5OMgBr. After the hydrolysis, it is converted into two molecules of phenols and two molecules of magnesium bromohydroxide, MgBrOH. This is another important method for the preparation of phenol. This is from cumene or isopropylbenzene. To prepare phenol, cumene is first oxidized in the presence of air of cumene hydroperoxide. cumene is oxidized into cumene hydroperoxide. Then cumene hydroperoxide is treated with dilute acidic water to prepare phenol, and acetone is the byproduct. So in the first step, cumene reacted with oxygen. It is converted into hydroperoxide. Hydroperoxide is in acidic medium, converts into phenol and prepare acetone as a byproduct. This is the detailed mechanism of the reaction in which oxygen radical, oxygen molecule has double bond in between the two oxygen atoms. By the homolytic cleavage, this oxygen radical or molecule attack on the cumene molecule and convert it into cumene hydroperoxide. Cumene hydroperoxide in acidic medium, first there is the attack of water molecule. After the attack of water molecule, removal of H2O. So two oxygens present in the hydroperoxide, one oxygen is eliminated in the form of water. After that, again there is the addition of water, and at last it is converted into phenol and acetone. This reaction is also used for the preparation of acetone. Next method is phenols can also be prepared by Dow's process. In this method, chlorobenzene is heated with 10% caustic soda or NaOH solution at high temperature and 200 atmospheric pressure in the presence of copper catalyst. First step is the preparation of, if we don't have chlorobenzene, then chlorobenzene can be prepared by the reaction of benzene and chlorine in the presence of iron catalyst. So there is the preparation of chlorobenzene. When chlorobenzene is treated or heated with concentrated NaOH solution at very high temperature like 350 degrees centigrade and 200 atmospheric pressure, in the presence of copper catalyst, it is converted into sodium phenoxide, and sodium phenoxide converted into phenol in the acidic medium when it is treated with dilute acid. So by the Dow's process, main thing is that chlorobenzene treated with concentrated NaOH at high temperature and pressure in the presence of copper catalyst, formation of phenoxide or sodium phenoxide in acidic medium converted into phenols. Next method. This is the last method for the preparation of phenols by Raschig's method. In the Raschig's method, the main steps are the production of chlorobenzene from benzene, hydrochloric acid and oxygen, and the subsequent hydrolysis of the chlorobenzene to the phenol. There is the difference between the Dow's process and the Raschig's method. In the Dow's process, we can use the chlorobenzene prepared by the benzene by the reaction of chlorine and FeCl3. In the Raschig's method, chlorobenzene is prepared by the reaction of benzene with HCl and oxygen in presence of copper chloride or iron chloride and form chlorobenzene. Chlorobenzene, when it is exposed to high temperature, its aqueous solution is boiled at high temperature, it is converted into phenol. So there are 8 methods for the preparation of phenols. Generally, or most important methods are the preparation of phenols by diazonium salt, by Grignard reagent, by haloarenes, by Dow's process, etc. Thanks a lot. And by cumene methods. That was the related to the preparation of the phenol. Thank you.